Okay, so this question here, tell me what is this about? Which topic? I know so far you only have like 5 topics, right? Correct, not scientific endeavors. What's the second topic? What's the second topic that we learned? Now, you are still telling me the topic you learned in primary school, but secondary school, you can't remember the topics, is it? There's it's not uncommon. Many students also cannot. Okay, like Madhav is telling me this is the chapter on heat. Yeah, now you change. Chemical composition of matter. Is it chemical composition? Are you very sure?
I think it's materials and its properties, the physical properties of matter.
You think that is the physical properties of the materials. And yep, that's right.
Thermal conductivity.
So what kind of properties are these? Is it chemical properties? Okay. No worries. Ananya, you can still do after, So that means you can still go back to the old one, do it. And then after that, you text me. I will go and take a look at your answers. This is what I do for the P6s also. Like 5 of them did not do the paper, right? They did it over the weekend. They messaged me and then I went in to mark for them. Yeah. So this is the kind of thing I can help you all with lah. But you have to do it. If you don't do it, how? There's no way I can help you also. Okay, this is the physical properties of matter. Good. So if you look at the question here, are you able to come up with the answers? So there are 4 identical rods, isn't it? Okay, so specifically, it is talking about the conductivity. What conductivity is this? Thermal conductivity. Okay, so this is on thermal conductivity. You can also call it heat conductivity, but when we talk about heat conductivity, we're referring to primary school. Secondary school, usually they like to talk about thermal. They change the word. Okay, so they are all heated to 100 degrees Celsius and then left to cool over a period of 10 minutes. Results were recorded in the graph below. Which material is most suitable for making a container to keep food warm? So your answer here, wow, everybody got it correct. Why did y'all choose that answer? Why did y'all choose that answer? Those of you who have not done this, right? Maybe you want to try now as well. Just type into the chat. What is your answer? Okay. You want something that can help to keep food warm. The rest also can try. Like Nikki, I know you want to try. Go ahead. Yeah, very good. Yes, correct. So people who are giving me the answers now, they didn't do the worksheet earlier, right? Yeah, that's right. Okay. Celestine, that's not the correct one. Okay. So, yes, we choose the answer as A, right? Why? Because look at the temperature decrease. Now, the temperature decrease, what is it trying to tell us? Okay, the temperature is decreasing so slowly. That means what? Loses heat slowly, right? So what kind of materials lose heat slowly? What kind of materials lose heat slowly? All right, some examples are like plastic. Yes, very good. Poor conductors. Yeah, that's the term I was looking for. So poor conductors of heat, right? Poor conductors of heat like plastic, like styrofoam. Very good. So anything that actually loses heat slowly will also gain heat very slowly. You all recall that? So whenever something loses heat slowly, it will also gain heat slowly. So that is what you all got to always remind yourself. So now you want a container that can help to keep food warm. Isn't this going to be the material that you will choose? If you're going to choose something like D, right? Okay, if you look at D, the temperature actually dropped very, very quickly to even room temperature, 25 degrees Celsius probably. What does it tell you? It could be something like metal. If you put something hot into a metallic container, okay, metal actually lose heat very fast because it gains heat fast, right? It's going to lose heat very fast also. So it's going to cause that hot substance, okay, to lose heat very fast as well. All right. So this one should be clear to all of you. Next, 3 objects of different shapes are cut from the same sheet of steel. Keywords here, same sheet of steel. The mass of different objects are shown below. So you have one with 1 gram and then 1.2 gram and then 1.5 gram. So which object will have the greatest density, highest density? I think we went through it last Wednesday, right, Evan? We talked about density, you recall? What did I say about density of water? Do you still remember or not? If I put water in a small glass and then I put water in a big container, then I put water into bathtub, which of them will have the greatest density? All the same. Wow, heng, I was like, what is he going to say? The bathtub. Please don't say the bathtub. Please don't say bathtub. Okay, good. All the same because it's still water. Doesn't matter how much of water I have, It's water is going to have the same density. Now, density is actually calculated by what? Mass divided by volume, isn't it? You all still remember this? So density is calculated with this formula. So if let's say I have maybe one material, let's see what is the density of steel. So it says density of steel is about 7.85 gram per cm cube. This is for steel. And then let me look at the density of another substance. Okay. Maybe I just stick to water can stick to water since I talk about water. Okay, so density of water is actually 1 gram per cm cube. So if let's say I put water, some amount of water, maybe 1 liter. Okay, so 1 liter of water. Do you know that 1 liter of water, right? 1 liter is actually 1,000 cm cube. If you don't know the conversion, now you know, okay? Then 1 liter of water is actually 1,000 gram. That is standard for water. So if I have 2 liters of water, it will be 2,000 gram, right? So 2 liters of water means what? 2 liters will mean it is 2,000 gram and the volume is, 2,000 cm cube. Calculate the density. So I got 2 liters big container, 2 liters of water. So density of water is actually 2,000 divided by 2,000. Mass divided by volume. Isn't this just 1 cm cube? 1 gram per cm cube? If I have 1,000 gram divided by 1,000 cm cube, isn't this the same? 1 gram per cm cube? So if now I have a big bathtub, we need quite a lot of water. Maybe about, this is a huge bathtub, I'm talking about 50 liters. So 50 liters is what? 50 liters, okay, is going to be 50,000 cm cube. And this is 50,000 gram. So if I calculate density, is it still the same? It's always the same because it is pure water we are talking about. If you want to put more water in a certain container, more water means volume is more. When volume is more, the mass is also increased, right or not? Correct? Then you divide out, it's still going to give the same density. So density is not about how big a container you are using. The density of that substance is about what is packed in that volume or in that space. Clear? Okay, so water is just water. We cannot say that, oh, because I use huge bathtub to put water, the density of water is higher. That means you don't have conceptual understanding. Clear or not? So in this case, okay, now we talk about steel, right? So no matter what is the shape or what is the mass over here, the density will be exactly the same. But we can use the information to calculate what is the volume of the L-shape steel. What is the volume of the square piece of steel? What is the volume of that steel disc? Agree or not? Using that info. Okay, so in this case, all of them will have the same density because they are cut from the same sheet of steel. Clear? Okay. Let's go on. Let me see. Evan, how come I see you answer wrongly over here? What happened? When I ask you, you can answer me. I look at your answer over here. Huh? Okay, never mind. Madhav, yours is correct. Serena, you're correct. The rest of you all chose C because it has got higher mass, right? Cannot. From now on, you must remember, don't overthink. The problem with people who study the problem of people who study even higher level is that they really overthink. You ask a small child, they will tell you the answer immediately, okay? And they will be correct. Yeah, Hannah, now you understand? You saw my working for water, right, Hannah? So I think you probably understand now. It doesn't matter. Yeah. So even if, let's say, I have 1 drop of water, does it mean that it has low density? No, its density is still the same, but the volume is so tiny, but its mass is tiny too. Yeah. All right, question 3. A student is trying to dissolve 60 grams of solid X in 100 ml of water. So now you are supposed to look at the graph, right? Okay, it shows how temperature affects solubility. Okay, the standard volume of water is 100 ml. At what temperature would she be left with 20 grams of undissolved solid X? So, at the start, there was 60 grams of the solid, okay? Then at the end, left with 20 grams. All right, so how much has dissolved? How much? 40 grams, isn't it? Yeah, 40 grams dissolved. Okay, so 40 grams actually dissolved. So are you able to find the answer now? Okay. What's the answer? The answer says it's C. Okay. I know why some of you struggle with it. Because if you are going to say, okay, maximum mass, you should be here, right? So you're struggling to find the temperature between 60 and 80, yes or not? Okay. All right. So that's why some of you chose D, right? Okay. So answer closest is this. Yeah. So if you ask me, I think this is not set very well. This is one of the school exam paper. I just estimated to closest. Okay, can. All right. Next one, question 4. Which substance is a compound? Define compound. Define compound for me. Let me see whether you all still recall how to define this. Tammy can define or not, Tammy? What is the definition of compound?